optimal system operation, and that power system security. Secured power system is one with low probability of system blackout or ability of the power system to remain secure without serious consequences to any pre-selected list of credible contingencies. So mainly an operation of securely uh, operating power system is controlled by Energy Management Center and Energy Control Center, EMS and ECC. The energy management system is to operate the system at minimum cost with the guaranteed elevation of emergency condition. So the emergency condition will depend on the severity of violations of operating limits. The major violations results from the contingencies. So there are three major functions of power system security. So most of the security related functions deal with the static snapshots of the power system. They have to be executed at intervals compatible with the rate of change of system state. So system security comprise of three major functions that are carried out in an energy control center. One is system monitoring, contingencies analysis, corrective action analysis. System monitoring supplies the power system operators or dispatchers with the pertinent up-to-date information on the condition of the power system on real-time basis as load and generation change. The telemetry systems normally measures or monitors and transmit the data or voltages, currents and the current flow and the status of circuit breakers and the switches in every substation in the transmission network. Of other critical or important information such as frequencies or the generator output and the transformer tap position can also be telemetered. Di- the digital computers in the control centers then process the telemeter data and place them in a database form and inform the operators in case of an overload or out of limit voltage. Important data are also displayed on the large system monitors. Alarm or the warning may be given if required. Such system often work with the superior supervisory control system to help the operators to control the circuit breakers and operate switches and the tap remotely. Such systems are togetherly called SCADA system, supervisory control and data acquisition system. The second major security function is the contingency analysis. Modern operation computers have contingency analysis programs stored in them. These foresee possible system troubles before they occur. They study outage events and alert the operator to any potential overloads or a serious voltage violations, etc. For example, a simplest form of contingency analysis can put in a standard LP programs along with the procedures to step up the load flow data, and this allows the system operators to locate defensive operating states where a single contingency event will generate overloads or the voltage violations. This contingency analysis carried out the major emergency identification and what if simulations solutions to the um, problem which occurs. So the identification process will be in the contingency analysis stage. And the third major security function is corrective action analysis, which permits the operators to change the operation of the power system if a contingency analysis program predicts a serious problem in the event of an occurrence of certain outages. So this provides preventive and the post contingency control. So simple example is shifting of generation from the one station to another station. This may result in the change in the power flow or causing the change in the loading or the overloaded lines. So these three functions together consist of a very complex set of tools that helps in the secure operation of the power system. So let us see what are the system security states. The system security or the formal classification of power system security level was suggested by Fink and Caslen in order to define the relevant energy management system functions. So the diagram which is shown in the slide, which is more practical static security level diagram, there are major 6 levels in the security levels. So the in the figure, the arrowed lines represents the involuntary transitions between the level 1 to 5 due to contingencies. The removal of violations from the level 4 normally requires energy management center directed corrective rescheduling or remedial action, bringing the system to level 3, where it can return to either level 1 or level 2 further by the EMS directed one. So the level 1 and 2 normally represents the power system, normal power system operation. Level 1 has a ideal security but too conservative or and costly. The power system survives any of the credible contingencies without relying on any post contingency corrective levels. And the level 2 is a most economical but depends upon the post contingency corrective rescheduling. So level 1 is a secure level and level 2 is a correctively secure, level 3 alert, level 4 correctable emergency, level 5 non-correctable emergency, and level 6 is restorative. So once the system is restorative or it is given back to a normal operation, so then it is given back to correctable emergency, then from there it is given to the secure level, that is level 1. Next comes is a failure and the repair rate. So the failure and the repair rate, there are can be defined as the number of units, number of failures per unit time is known as the failure rate of the component. It is represented by lambda, and the lambda is the total number of failures by the total operating time. Similarly, repair rate can be defined as number of repairs per unit time. It is known as repair rate, and it is denoted by mu, total number of repairs divided by total operating time. So repair rate or the failure rate can be explained with the help of the curve called bathtub curve. So the picture shows the bathtub curve. So bathtub curve mainly consists of 3 parts. One is debugging period, second one is a useful period, third one is the wear out period. So it is a curve of failure rate versus the operating life. So in the debugging period or initial period is also known as debugging period or period of infant mortality. In this period, the failures may be high due to the errors in the designs or the manufacturing. These errors can be detected or removed in the initial period, and this region shows a decrease in the failure rate. To here, the failure rate is decreasing as shown in the curve. So from the higher level to the curve is decreasing here. So error may be due to a designs or due to manufacturing. So in the initial period only the errors are identified and it is tried to remove so that failure rate can be decreased in the debugging period. The middle portion is normal operating or the useful life. So in useful life, the failure rate is only due to chance and the failure is comparably low and failure rate is nearly constant. So you can observe the constant failure rate. So that means, so this is the most useful time. So failure rate is constant. So there is no increase in the failure rate. So how initially the debugging period was there. So how it is came back to a normal state. So in the normal state only the system is operating and this is a very useful time. So there is no damage in the useful life. So that the second period is a useful one and the third one last period is the wear out period. So we were wear out period or the old age, and in this period failure rate increases, you can observe in the curve. The and the repairs in these periods are very costly and therefore it is preferable to replace the component by a new one. So normally the power system is operated in the useful life for a long time and by useful and proper periodic maintenance. So that compared to the debugging and wear out period, useful life is a very most useful period. Then sensitivity factors. So mainly there are two different sensitivity factors. One is a generation shift distribution factor and the line outage distribution factor. Generation shift distribution factor, it can be defined as the change in the megawatt power flow on the line to the change in the generated power takes place in the ith bus. Similarly, the line outage distribution factors can be defined as change in the megawatt power flow to the pre-contingency line flow on the ith line. Next comes is a power system reliability. So the definition of power system reliability is reliability of a power system pertains to its ability to satisfy its load demand under the specified operating conditions and policies. So different indices of power system reliability, it is loss of load probability, loss of load expectation, loss of load frequency, expected unserved energy. So reliability mainly consists of two parts, adequacy and security. Adequacy related to the existence of sufficient facilities within the system to satisfy the consumer load demand at all times. Security relates to the ability to withstand sudden disturbances. Loss of load probability, LOLP, loss of load probability. Loss of load probability can be defined as probability that the total production in the system cannot meet the load demand. So this is the equation to write the loss of load probability, and the curve indicates the loss of load probability.